Welcome to our channel Circuits Analytica. In this tutorial, we will discuss a problem on nodal analysis to find voltage drop across the 3 ohms and 12 ohms resistance in the given network. Mark various nodes as P, Q, R, S and T. Mark various currents associated with the nodes Q and S. Voltage at node P is given as 240 volt and voltage at node T is given as 60 volt. Apply KCL at node Q. According to KCL, total incoming current is equal to total outgoing currents. Here there are 3 currents associated with node Q: current I1, I2 and I3. So according to KCL, I1 is equal to I2 plus I3, as I1 is the lone incoming current and I2 and I3 are the 2 outgoing currents. I1 is equal to voltage drop across 3 ohms resistance divided by 3. Voltage drop across 3 ohms resistance is given as Vp minus Vq. Therefore, I1 is equal to Vp minus Vq divided by 3. According to Ohm's law, I2 is equal to voltage drop across 6 ohms resistance divided by 6. Voltage drop across 6 ohms resistance is equal to Vq minus Vs. Therefore, I2 is equal to Vq minus Vs the whole divided by 6. And I3 is given as 10 amperes. Apply KCL at node Q. I1 is equal to I2 plus I3. That means Vp minus Vq the whole divided by 3 is equal to Vq minus Vs the whole divided by 6 plus 10. So Vp minus Vq the whole divided by 3 minus inside bracket Vq minus Vs the whole divided by 6 is equal to 10. Vp minus Vq the whole divided by 3 minus inside bracket Vq minus Vs the whole divided by 6 is equal to 10. Taking LCM as 6, 2Vp minus 2Vq minus Vq plus Vs the whole divided by 6 is equal to 10. 2Vp minus 3Vq plus Vs is equal to 60 and Vp is given as 240. Therefore, we will get minus 3Vq plus Vs is equal to minus 420. Equation number 1. Apply KCL at node 6. There are 3 currents associated with node 6: I2, I4 and I5. I2 is the incoming current while I4 and I5 are outgoing currents. Therefore, according to KCL, we can write I2 is equal to I4 plus I5. According to Ohm's law, I2 is equal to Vq minus Vs the whole divided by 6. I4 is equal to voltage at node S with respect to reference node minus voltage at node R with respect to reference node the whole divided by 30. I4 is equal to Vs divided by 30. According to Ohm's law, I5 is equal to voltage drop across 12 ohm resistance divided by 12. Voltage drop across 12 ohm resistance is equal to Vs minus 60. Therefore, I5 is equal to Vs minus 60 the whole divided by 12. So I2 is equal to VQ minus Vs by 6. I4 is equal to Vs by 30 and I5 is equal to Vs minus 60 the whole divided by 12. Apply KCL at node S. I2 is equal to I4 plus I5. VQ minus Vs the whole divided by 6 is equal to Vs by 30 plus Vs minus 60 divided by 12. So rearranging the terms, we will get VQ minus Vs the whole divided by 6 minus Vs by 30 minus Vs by 12 is equal to minus 5. VQ minus Vs the whole divided by 6 minus Vs by 30 minus Vs by 12 is equal to minus 5. Taking LCM as 60, 10 VQ minus 10 Vs minus 2 Vs minus 5 Vs the whole divided by 60 is equal to minus 5. Rearranging the terms, we will get 10 VQ minus 17 Vs is equal to minus 300, equation number 2. So we have two equations. Minus 3 VQ plus Vs is equal to minus 420, equation number 1. 10 VQ minus 17 Vs is equal to minus 300, equation number 2. In matrix form, these equations can be written as matrix of minus 3, 1, 10, minus 17 into matrix of VQ is equal to matrix of minus 420, minus 300. According to Cramer's rule, we can write VQ is equal to delta 1 by delta and Vs is equal to delta 2 by delta, where delta is equal to determinant of minus 3, 1, 10, minus 17. Delta 1 is equal to determinant of minus 420, 1, minus 300, minus 17. And delta 2 is equal to minus 3, minus 420, 10, minus 300. So we will get delta is equal to 41. Delta 1 is equal to 7440. And delta 2 is equal to 5100. Therefore, we will get VQ is equal to 181.46 volt and Vs is equal to 124.39 volt. So voltage drop across 3 ohms resistance is denoted as V1. V1 is equal to 240 minus VQ. That means we will get V1 is equal to 58.54 volt. Voltage drop across 12 ohm resistance is denoted as V2. V2 is equal to Vs minus 60. So we will get V2 is equal to 64.39 volt. So finally, V1 is equal to 58.54 volt and V2 is equal to 64.39 volt. Voltage drop across 3 ohms resistance is 58.54 volt and voltage drop across 12 ohm resistance is V2 is equal to 64.39 volt. Thanks for watching Circuits Analytica. Enjoy learning.